I try and stay away from introducing speakers with technical topics. So, being that I know Michael, I'm going to let him kind of introduce himself. He can talk to you a little bit of his background, and then we're going to jump into the presentation.
Okay.
Thank you for being here, Michael.
Thanks, Ernest. That was interesting intro. So my name's Michael Wright. I'm actually the acting CTO at a startup company here in Charleston called Bisbee International, and also own my own consulting business called Sandlapper Technologies. So the talk today is basically going to be on a project that I actually worked on for Bisbee, and I'm going to kind of take you through building a set of APIs that I did for them, and some of the hoops I had to jump through and some of the problems that I ran into based on the requirements that I was given. So let's first start with the problem that I was given. So I met with one of the co-founders one day, and we kind of, he started going over what he wanted me to do. So the first thing is he needed a mechanism to basically get data out of a database or out of a server and put data up there. So for his clients. Oh, okay, I can definitely do that. He wanted to be able to handle millions of people hitting this thing. Okay, so what does that mean for me? I'm going to need a scalable system also. Well, by the way, we're a startup. We have limited DevOps support. Actually, they have no DevOps support. So, we'll have to handle that case also. Of course, we've all seen this as developers. Need something as soon as possible. Because they're, again, startup. It's all about cash is king and getting something to market as soon as you can. There again, back to the startup piece. I don't have very much money, so I need to do it at a low cost. So how am I going to do this? So one, I could go out and provision my own servers. I could create my own load balancers. I could build my, failover infrastructure, all that kind of stuff. Still be able to accomplish everything that was on that list, except for maybe the low cost piece, because that is going to take up some time and money. I could use some services like Elastic Beanstalk that AWS provides, or Google App Engine. That definitely starts to check my list off even more, because now I can write my code, I can put it out on Elastic Beanstalk. It will do the load balancing for me and scale servers up and down as needed. So that might actually be a good option. But I've been listening and reading a lot on this architecture that a lot of people are talking about called serverless. So, and about a year ago, I actually saw Tom Wilson do a presentation on AWS Lambda. And I thought, well, hey, that's kind of cool, so let's try to go serverless. So what is a serverless architecture? So the word serverless is a bit of a misnomer. So there are servers on the back end running your code. So it's not like this magic piece out there where your code's floating in. So this is my definition. Serverless is about running code in a compute service which you do not have to manage. So a lot of people come up with, or people are starting to kind of come towards 5 principles of a serverless architecture. So the first one is, of course, using a compute service. So you don't want no servers. You don't want to have to manage that. Writing a single-purpose stateless function. That's extremely important when you go serverless, because you want your functions to be as small as possible. You want them to do one thing, and you want them to do it really well. The other thing is to design push-based, event-driven pipeline. So what does this mean? Actually, if you go to the AWS site and you look under Lambda and you look under some of their other services that they have, they love to use this, this example, and a lot of people use this example, and that is, I push an image or a video up to S3. When it hits the S3 bucket, an event fires, which actually calls a Lambda function, and that Lambda function does something. It may convert the video or it may schedule the transcoder, which is another service that they have to go do something with the video. But that's all it does. It does something really quick and then it leaves. It doesn't go off and try to write to the database and do 100 things at one time. The video gets processed, gets dropped in another bucket, then another event fires that fires another Lambda function, and then that function actually does one thing and it does it really well. Maybe it writes to the database. From there, the database could trigger another event and so on until you notify the user. So, that's a big deal. A long time ago, in technical terms, that could be 6 months ago, but years ago, we always talked about writing thinner front-end clients and everything. That's starting to shift to be a little bit more thicker on the front end, because now we have all these services. We have signed tokens that we can pass around, so security is a little bit better. So now to start to create that thicker front-end service. And then the fifth one is embrace third-party services. So when I actually started my development career, I worked in government contracts, and one of the first projects I worked on actually was a greenfield project, and we wrote our own string class. I mean, who does that today? There again, that was decades ago too. So, now, I mean, if you have a need for an authentication service, maybe you use another service like Auth0, or if you need to take credit card payments, maybe use Braintree. So there's all these services that do stuff really, really well. That's their expertise. Maybe use these other services. There is a caveat to it. You have to watch that you don't want to get into a vendor lock-in. So you want to make sure that your architecture, your code, and your service in a way that you could get out of that if you need to. So let's talk about some pros and cons to this. So one of the pros is now I can kind of focus on my code instead of focusing on the infrastructure, building servers and load balancers and all this kind of stuff. No more servers to maintain or patch or configure. That's always a good thing if you've ever had to do that. Low cost. I'm only going to pay for what I use. Most compute services that I looked at out there, you pay based on your compute cycle or how much time that you're using. It's scalable and it's flexible. That's the whole purpose of using it, is so that it can scale out and scale down as needed. But some of the cons here are, one, especially for and I'm starting to talk a little bit more about AWS here, is Lambda runs on EC2, so it runs in the public cloud. Now, when I say public cloud, that doesn't mean that, I've uploaded my code and everyone can see it. That's not what I'm talking about. What I'm talking about is when your code is running, the CPU cycles that it's using is actually shared, and the memory is shared with other people that are out there. Along that same lines are SLAs. So if you have a service, an existing service, or you're building a new one that has this really big, like 5 nines or something like that on an SLA, maybe you need to look at these compute services. Might not be what you need. So in the case of Lambda, like I said, it runs on top of EC2. So you're actually running with an SLA at whatever EC2 is at the time. And I believe that's 9995 or something like that. But you got to definitely be careful with that. And then I mentioned this one, vendor lock-in. You start to, if you architecture your code the wrong way and you really depend on one single vendor, and all of a sudden that vendor goes bankrupt, or they decide to quadruple their price each month, oh crap, what am I going to do? So you want to definitely keep a look at that. And one of the biggest ones, and I'll talk about this a little bit more, and that's debugging. One of the things you got to remember on a serverless system is it's serverless. Before, when you actually owned the server and you pushed code onto it and you needed to debug something, you could log into that server and maybe do some things. You don't have access to these servers anymore. So makes debugging a little bit interesting. In a lot of cases, you hear some developers always say, well, it works on my machine. Well, I've actually experienced that in building this project where all my unit tests work. Everything is working on my machine as I'm testing it, but I push it to the cloud and it's working, but then all of a sudden I start getting timeouts. Why? How do I debug that? So we'll look at that also. So let's look at Lambda a little bit. So Lambda runs code without provisioning or managing servers. That's a good thing. I'm only going to pay for the time that I use or that I consume, and it automatically scales as needed. That kind of came right off their website or whatever. That's their marketing stuff. So looking at these three things and going back to my problem statement, have I actually solved my problem? Is this the path that I need to go down? So let's look at those. One, I need a mechanism for clients to get and save data. All right, well, that's just me writing code. So yeah, I can check that one off. Ability to handle millions of users hitting these APIs. Well, it automatically scales as needed, so I'm going to check that box also. Limited DevOps support. Well, I don't have to provision or manage servers or anything, so let's check that box too. And then I need something as soon as possible. Well, this is an interesting one. But now that I don't have to manage the servers, I can actually focus all my time writing my code and getting it deployed. So I'm going to check the box on that one. And then, of course, low cost. Well, I'm only paying for the cycles that I use. And in the case of AWS, when you sign up, you get that free tier. It's kind of like somewhat like a drug dealer, I guess. They get you hooked, and then they charge you after a year. But even with Lambda, I can't remember, there's like 1 million seconds or something like that per month that you can use in execution time. And even after the first year, it still it works out. And I even calculated it, what we're running. If I used that up, or if I doubled it, we're only still talking $5 or $6 a month or whatever. That's not bad when I don't have to manage any of the servers. So let's look at my the architecture of APIs. So there's 3 ways that I could build this thing. One, I can build it in a monolithic fashion. So that means that I'm going to take all my code and I'm going to shove it right into one single Lambda function. Not the best thing to do, I don't think. Let's not do that one. So microservices. Well, I could separate all my resources, and I could put all the code for each resource into a Lambda function. A little bit better. Or there's a concept of nanoservices. And in this, I can actually break it down to even a more granular level and put each verb from the REST API, so like a post or a get, put delete, into its own Lambda function for that resource. So for me, I actually chose the middle one. Why? I can tell you afterwards. That was one of the pieces I cut out of the presentation. So, because the presentation is too long. So let's look at the diagram. Just real quick to kind of go over this. I have the user here with their device. They call our REST API. That actually goes through the Amazon API gateway, which invokes a Lambda function. The Lambda function then can either talk to S3 if it needs to. It also can talk to Amazon DynamoDB, which is basically a NoSQL database. So think of like a MongoDB. And this little green piece up here on the top, this is a CloudWatch. It's actually something you get automatically when you're using Lambda. But in my code, if I want to log out a message or an error message or any type of trace, it will actually go up here to CloudWatch. So think of it as just a big logging piece. But the nice thing about it is up here we can set filters and alerts so that if I'm, like I told you earlier, I was having timeouts, I actually created a really simple alert that was filtering the logs real time. And if it would see 3 timeouts within an X period of time, I would actually get a text message, or I'd get a Slack message or an email or something like that. So there's ways that you can set that up. You know, I have CloudFront here. If you're not familiar with AWS services, basically CloudFront is nothing but a CDN, content delivery network. And that's just a way, That's a way of just caching your content at endpoints and everything. But we're not going to go into detail on that one. And also, if you notice here, my Lambda function can actually call out to non-AWS services too. So for authentication, Visby is actually using auth0. Now, the interesting thing is this is the entire architecture of all the REST APIs that we've built so far. And I haven't provisioned one server yet. And I was able to accomplish all of it. I have my monitoring, I have my authentication, I have data storage, I have all my processing, all my error handling, everything, have it set up on a single server. So the next thing I want to do is, it's really not demo time, but I want to show you a little bit of code. I'm not going to sit here and write code in front of you because that's a bad thing to do in a presentation live. But I do want to show you some of the structure and what this looks like. And really, how did I go through it? I want to also keep an eye on the time. So let's move over to, if you've ever logged into AWS, this is what you get, the console. Wow, that's overwhelming, or whatever. They have tons of services. The first time I ever logged into AWS, I think they had maybe this many. And that was it. So they're always releasing new services. Have I drank the Kool-Aid? I've drank half the glass, so which is maybe not great. But here we're going to look at Lambda, which is the compute service. Now, Lambda, you can write your code in Java, you can use Node.js, or you can use Python, which I have a friend that says Python is like the ultimate language. So, but we won't discuss that either. So let's look at a really simple function here. So this is a Lambda function that you can write. Neat thing about it, they actually give you a little text editor that you can write your functions in. And this is how I started. I basically, after 25 plus years of software development, I started with Hello World, pretty much. I think most developers do when they're learning something. But the important piece here is the Lambda function always has a handler. That's the entry point to it. Now this is Node.js. I'm not here to talk about Node.js or anything like that. And for those that are not developers, just hang with me for a little bit here. So in this, you can pass in an event, a context, and a callback. So the event is really all the data that you want to pass into that Lambda function so that it can go off and process. It's everything that it needs. Recently, in the last 4 weeks, they've actually changed this. It used to be just event and context, but they upgraded it. It is backwards compatible still, but they have added this callback, and the context variable actually has a lot more data in it. So one of the things with Lambda is, you remember, you're running in a time slice. So you want to run that code as quick as possible, so when you configure your Lambda function, you're going to tell it, this is the timeout. If this function runs longer than this, shut it down. I don't want it to run anymore, and it's just going to kill it. So the context will actually give you things like how much time is left on the clock. It will tell you how much memory is going on. If a mobile device is actually calling the Lambda function directly, which you can do through the SDKs, it will actually give you a ton of information about the mobile device. So it's actually pretty cool what they've added to that variable there. Couple things I want you to note is this date that sits outside the handler. That's important. And I have a date here inside. So basically what this is going to do is when we run it, it's going to take whatever the event is, and it's pretty much going to echo it back out to the caller, adding 2 extra parameters, a date and a process date. So the nice thing about Lambda is they give you this internal test, so I don't actually have to go and write other code. I can test it within here. So if I test this, let's hope that this works. The results come down here at the bottom, and we notice we got our 3 values. Basically, I passed in some 3 key value pairs into the function. It added the date and the process date. And you notice these dates, date and time is almost exactly the same. The milliseconds are a little bit different. Also notice down here that I can see what was output to CloudFront. If we wanted to, click into CloudFront, this is kind of what we would see. And also we see the duration of how long it took to run, how much I'm going to be billed for, and then the resource config and how much memory was actually used. One thing to note on these, this is a little bit deceiving. I actually had problems with this. So when I wrote one of my final APIs actually was going to deploy it, my max memory was running at 50, 60 megs. Not much or whatever, so I figured, 128 megs resource configured, and that's one of the configurations that you put, is plenty, because I'm not using that much memory. But I noticed that my startup time on the Lambda function was like 3 or 4 seconds. Well, but after that, after the startup time, I was seeing, 500 milliseconds, 400 milliseconds, 300, it get faster and faster. Well, one of the things that you have to notice is as you bump the memory configuration up, actually AWS gives you more and more CPU power too. So they're linked together. So if you want to if you got a really massive lot of code that you're putting in your package, you really need to bump this up 512, maybe even higher. But remember, you're paying based on time and memory usage. That's this memory usage, the configured value. So you'll want to run some calculations there. They actually give you a calculator that you can do all this stuff. And sometimes you will find, even though you think, well, shoot, I don't want to pay for more memory, if this drops your running time by 80% and you're making hundreds of thousands of calls, it's actually cheaper to use the higher memory than to let it run longer. So let's run this thing again, since I've talked a little bit, and we're going to scroll back down to the bottom, and we notice that this time it only took 1.2 seconds, 1.2 milliseconds for it to run, instead of, I think the last one was, what was it? 12. So you can see that's the difference in the startup time on this one. The other thing I want you to note is the date up here. You notice that this date is much higher than this one. And that is because when we defined that date value, we did it outside of the handler. So anything that you define outside this handler is called once. And that's when the Lambda function starts up. And that is a key thing for speed. So if you have database connections, anything that takes a long time to configure that you don't want to configure every time it's being called, put it outside the handler so that when that Lambda function starts up, it creates everything and you're good to go. You just reuse it. If not, you'll end up recreating it every single time that you're inside the handler. Well, for the developers in the room, you're probably thinking, well, I can't write all my code in this little console here. I need something more than that. So I love using my own editor. So I need to write a bigger Lambda function. I need for it to do more. I need to bring in other packages like this validation package where I have additional files that I need to bring in from the library and everything. So I still have my handler here defined the same way. This is going to be a database connection for me to AWS or to DynamoDB, and I put it outside, declared it outside the handler, and then basically I'm going to set it inside the handler, but I will reuse it over and over. And then I've created all these different functions here. I have a function for getting data from DynamoDB. I have one for putting data, either an update or an insert into DynamoDB. I can delete data, but here's the main piece. So it's going to come in and it's going to read this method parameter off of the event that's being passed in. And from that, and when I talk about method, I'm talking about my REST APIs. So for those that don't know much about REST APIs, I'm not going to go into detail, but REST APIs have these verbs, get, put, post, and delete. So get means I'm going to go get something. Post normally means that I'm going to create something. I'm going to pass in something through the API, and it's going to create that record in the database or on disk or something else. I'll put, think of it as an update. And then delete is what it says. I'm going to go delete whatever you're talking about. So I have all these values here. Now, how do I get that into Lambda? So I have all these files and everything. So how do I get that up there? Well, one, I could go and zip all these files up because the Lambda console allows me to upload a zip file. Or I could zip the files up and put them on S3, and the Lambda console allows me to use something off of S3. Well, that's really cumbersome. I can't do that. That's just too much work, and a lot of developers are lazy. So when they're lazy, they actually start writing things, utilities, so that you can type it on a command line and it does it for you. Because you want to do it the same way over and over. You don't want any mistakes there. So what I do is basically I've used a utility called Gulp. You can use whatever you want to. But I've created this task that basically deploys my Lambda function for me. So how do I do that? One, I have to get all the code together, put it in a directory that's clean. I'm only using my production data too. So, you know, when you're using a lot of code, you can have a whole bunch of dev utilities that you use, like for your testing. You don't want to push those up to Lambda. You only want to push up the production files that are needed. So that kind of happens in this. I zip up that data and then I upload it to Lambda. So uploading it to Lambda, and we'll just take a really quick look at this, is basically using the Lambda API here. So I can take the Lambda API and I can set up all the information I want, like my timeout, the memory size that I want, the function name. There's some other things in here as far as the role, and that was another challenge for me, is getting the roles set up right. They don't, in my opinion, it's not all that easy to do. It can, you know, you can definitely do it, but it just takes a little while to get through that. But basically I go and I search for that Lambda function here. If it's not available, I take the zip file and I basically upload it, or I call the Lambda function create function, and that uploads and basically creates the Lambda function for me, and it even publishes it. So it's active, ready to go at that point. If the function's already there, I use this update function code, which basically uploads the new code to Lambda, publishes it, and makes it active right away. So what does that look like? Well, before I show you that, I want to show you something else. So one of the other things that you want to do is unit tests. I love unit tests. I believe in them. I know that's one of the documentation and unit tests are the first two things that get dropped in development. But I can tell you from experience, if you actually write good unit tests, it will save you in the long run. So in my case, with this project, I can't remember, I have a few hundred unit tests, I think, that run through all the APIs. And when I found that timeout, I decided to go back and rework a core piece of the API that's underneath the hood. And because I had all those unit tests, all I had to do was go and change my code and just keep rerunning the unit test until everything passed. And then I felt confident that I had it right. Because I hadn't changed my interface at all. All I was doing is changing the underlying code. So unit test, I use Gulp also, but I'm using DynamoDB, so how do I test with DynamoDB being in the cloud, and I'm having to pay for it, and all this other stuff. So AWS actually wrote this nice little Java package that allows you to install DynamoDB locally on your box. So with that, you can run it in two ways. One, you can run it so that it persists the data on your machine, your laptop, by putting it into a file, or you can run it in memory so that basically everything is stored in memory. As soon as you shut it down, it's gone. And then when you start back up, you start with a clean database. I chose the in-memory one because I have all this test data that I'm loading up into these tables to do my testing with, and I didn't want to have to, at the end of every unit test, have to worry about have I cleaned up all the data, because I want to start with a clean slate each time. So here, I'm going to run, just real quick, we're going to run DynamoDB in memory. So that's running, and now I'm going to run my test here, and let's keep our fingers crossed. Yep, both of them passed. I only had 2 tests, but now I feel like everything's good, so I want to deploy it. So that deploy piece that I told you about, that I showed you, that task, basically I just type in Gulp deploy. Let's hope our internet connection is up. Please, yes. So there you go. So the function has been deployed to my dev environment, and it's actually active. Anyone can access it that I've given them permission to. So that is done. So now I know how I can update my code, and I can push it up to the cloud. So given that, now I need to write my API, because really all I have is my code that's accessing the database. I still don't have my API written. So the next service that I looked at using is the API gateway. And I'm going to go through this one pretty quick. You can come in here and you can define REST APIs fairly easily. You can define a resource, all your verbs, and these names should start looking familiar for those that are less technical. But some of the key pieces that I had problems with, and I just want to point those out, is you can actually test this internally. So without going to Postman or using some other testing tools, you can test it right here within that. I highly recommend doing that. That's kind of what I did. I also stayed in the console here a good bit while I was developing my API until I really understood how it worked. And then after that, you have a way that you can export that to a JSON structure. And now I actually never come to this page anymore. I update my JSON structure, and I have a command line parameter that I run, and it pushes my APIs back up and updates them, publishes them, whatever I need it to do. It was kind of interesting because when I built this little demo here, when I came in, this UI has changed since the last time I used it. So they're always updating it and making it better. But the one piece I want to show you, that another place that I had problems with, and that is in this mapping template here. So you got data coming in from your client or from someone's device that's coming through your API. Now, how do you get it to the Lambda function? So you have this mapping templates area. And in my case, I made the choice that all data is going to be application JSON. So I'm not going to handle XML data or anything like that. And it's just, we've documented our API saying this is what they do. You know, if the client doesn't like it, well, they can use it this way or don't use it at all. So I've created this content type of application JSON, and then I had to build this template here. So this actually gave me a lot of problems. This is written in, AWS uses this thing called the Velocity Template Language, VTL, and it's an Apache project. And I didn't really know anything about it. So, and that's kind of what, you know, it was like. And the AWS website at the time didn't have a lot of examples. But doing a little bit of Google searches, and I found some people that wrote some really nice templates. You can go out there and pretty much copy and paste and put into your code, where they iterate over things and they use the language. They know what they're doing. So I've been learning from that. But the nice thing about this is now I can start picking up on maybe some data that I want to capture on my back end. So When you're doing web development or REST APIs, a lot of times you want to know what the user agent is. You want to know what browser it's kind of coming from and some of that other information. This is data that the browser sends just naturally. For those that like to surf the web and don't understand what's going on, there's a lot of data being captured every time that you go to a website. This is one of them, the user agent. So we kind of pull that out. The AWS gateway allows us to do that. I can pull the source IP. So if you're sitting at home using our app, I know what IP address that you're sitting on, unless you're going through a VPN. And sometimes I can even tell that also. And here's that method that we talked about. So instead of me hard coding the method, like I know that this is the post verb that I'm working in, I don't actually have to hard code that it's post. It will tell me by using just the $context.http method, and it will pass it in. And then of course, this is the data that I'm passing in. So this was a little bit of a challenge here. The other thing that a lot of times that I found that was interesting to do is, we'll look at the get here. Down at the bottom, you have these method responses and the integration responses. So when you're getting returns from API, you always get a status, like a 200 OK or a 201 for create, or 404, whatever it may be. So you have to do all that mapping down here yourself. This is where it starts getting tedious. So this is why I kind of spent a little bit of time on here. I got my API the way I wanted it, and then I exported it. And then I'm doing everything basically in a text editor now with the JSON string. Because if I need to add another status, I just go into the JSON, I drop the new status in, I can drop the mappings in, and do a command line call, and all that stuff gets pushed up, and I'm not clicking through all these things. I'd rather spend my time on the command line than on a page like this. So there's a couple other things. So if after I deploy the API, what I get is this massive URL. Boy, that's ugly. So that's the URL to my API, if I wanted to call it. And you probably don't want to give that to your clients to call. So what you can do is you can create custom domain names. They have to have a certificate tied to them. They require that. So you can actually create your own domain, and then that URL will point to that domain, so the end user doesn't see that. You can also create stage variables. This is really important. Think of this as environment variables for those that do development. And you can take these stage variables and put them into the event that's actually getting sent to the Lambda function. And that's a good way, like for us, I told you we use Auth0 for our authentication. A lot of the important information, the things that you don't want people to see, the secret keys and everything, we actually put them in stage variables because we have 3 stages. We have a dev, a staging, and a production stage. And each one of those stages has a different security key because we keep all the environments separate. And because of that, you can set them here. Only you have access to them unless someone hacks your account, which you try to use, or you should be using, 2-factor authentication so that people don't hack your account. And you can kind of keep them here and everything will pass through. You can also generate SDKs. After you get your API written, you can actually have it to export an Android or an iOS or a JavaScript SDK. We tried the iOS one. It was okay, but I'm the type of person I'd rather just call the URL a lot of times. You can also export these, export as Swagger or Swagger and the extensions, or even to a Postman extension. And you can also see your deployment history. So let's say you deploy something and all of a sudden you realize, uh-oh, I have a problem. you can always roll back really quick to the previous version. You just go in here, you click the button, and you say apply, and basically your API rolls back to what it used to be, which is very nice. So with that, let's go back to because we're running out of time, let's go back to presentation. And so we did that. So let's talk about continuous integration and deployment. I'm a big component of this. As I'm developing code, I showed you I can run a command line parameter and push my code up to Lambda. Well, wouldn't it be great if I checked my code into GitHub or into my source control and all that stuff happened for me? But it doesn't actually push it to Lambda unless all the tests pass. So I'm using this free service called CircleCI. If you have a GitHub account, you can get a free tier on CircleCI. You can only do one build at a time. If you want to do multiple builds, that's when you have to start paying for it. We're a small shop. I can only have to do one build at a time. Builds only take a couple of minutes anyway with the deploy time and everything else, so might as well do that. So I use that piece. I kind of showed you the deploy with Gulp and the Lambda APIs. Showed you that. Let's talk a little bit about testing. For testing, I use the Mocha testing framework. You can use whatever you're comfortable with. It's not tied to serverless development or anything like that. It's just what I was comfortable with. There again, I use Gulp. Again, to execute my test, you can use whatever you want. It's not, there's no hard standard there. Local DynamoDB, we talked a little bit about that. I use the local version just so I'm not writing everything to the cloud all the time. And plus, I'm able to run it in memory, which gives me a good checkpoint where I can always start with a clean database all the time. S3, when I go to test, I did find some packages out there where you can do like an S3 local on your machine, but to be honest with you, it looked really cumbersome and hard to use. So I basically stepped back from it and I created a test bucket in S3 and I shoved everything in that, and it was easy to write a little bit of code that iterates over the entire test bucket and just deletes everything out of the test. So I did that. I highly recommend that you load test your APIs. You want to make sure, basically, you've written everything and you have no control over these servers. So you want to make sure it's really going to do what you think it's going to do. Running it one time or hitting that little test button up there is not enough. So in our case, I didn't use a load testing framework. I basically just created some little simple apps. I put them on some EC2 instances on my laptop, and I ran a whole bunch of different instances and let it just beat the heck out of the API until it broke, and see what that breaking point is. The neat thing about it is you can limit your APIs. You can actually have thresholds so they can only be called so many times. So like if you get a denial of attack on your APIs, and basically the gateway will start rejecting the calls before it even calls your Lambda function. So you got a little bit of protection there. And as far as frameworks and tools, I built my own little tools and using Gulp and things like that. But there is this really cool framework out there called Serverless framework. It works for Python and Node.js, but basically it wraps and orchestrates a lot of this for you. So you go in and you build configuration files, and you can do command line parameters, run command line utilities, and basically push up your APIs and your Lambda functions all in one step, so that they stay in sync. I haven't used this yet. We did this presentation Wednesday at the AWS meetup, and there was a guy there saying that he was using it. His feedback was it's moving so quickly, it's changing almost hourly, that it was hard to keep up with sometimes. So I'm going to take a look at it probably in the next month, because I got to go build some more APIs and see how that is. If you're a Python person and you want an easy, clean way of pushing your code up, there's this Python Lambda out there that gives you a nice tool to basically push up Lambda functions that you're writing. And of course, AWS Labs. This is actually a lot of the AWS engineers contribute to this. There are tons of tools underneath this. If you're going to go this route, I highly recommend you go look at some of these tools. They even have, I believe, a tool that if you're using Git for source control, you can, a little utility that sits on top of it that will scan your code and look for AWS keys, because you should never check in your keys, your API keys, and it will actually prevent you from pushing your code up if it finds keys in there. So that's pretty cool. In summary, one, you hear me talk about the AWS API keys. Whatever you do, do not give that key permission to add users. You should never be, from like a command line interface, you should never be able to add a new user to your account. That's extremely dangerous. If you want to add new users to your account, you want your admin to be able to log in, two-factor authentication, and then add someone. So make sure that you're giving the right permissions. Keep your Lambda code as small as possible. Remember, you're paying for the time, and there again, you should be writing your code. In this case, in this architecture, you want that function to do one thing, you want it to do it really well. Also, it will help out with your debugging. The smaller your function is, the easier it is to debug, because it's not doing 100 different things. If it's broken, it should be pretty easy to find out what's broken. Initialize external services outside your Lambda code. Talked a little bit about that. Doing like database connections outside that handler will definitely help speed things up. One thing to note with Lambda, when you call it and it starts up, if you call it again, it's going to reuse that same container that it spins up. Now, eventually, it's going to shut that container down, and if you call it, it's got to spin back up and do everything again. Or if you're calling that container so much that it can't handle the load, it will spin up a second container, or a third, or a fourth. That's where the scalability is, and then it shuts them down as it needs. AWS doesn't tell you how long those containers stay up. I'm sure there's this magic algorithm that's on the back end saying, oh, there's so many people using it, so the time narrows or whatever, that if you go idle, it will shut you down sooner, or if there's not a lot of people, it may keep you up longer. So it's important to have some of those variables outside the handler. Load testing, talked a little bit about this. You want to definitely load test your stuff. And back to kind of that, the Lambda function spinning up and coming down. Continuous load, if you have something that's a continuous load, like someone's hitting you every second or every 5 seconds or every 10 seconds, but it's just constant, you'll get better performance because the Lambda function is always up. And a lot of stuff is cached for you, and you'll just get a lot better performance there. Instead of you're getting called and then an hour later you're getting called again, because in that case you're probably restarting that Lambda function, that environment every single time. The other thing with this, I got a question on Wednesday is which language is best to use. Use what, well, in the case of Lambda you can only use 3, Java, Node.js, and Python. So use what's best for you, what you know. There was a guy there on Wednesday that basically said they were using Java, and the startup time was really slow. And of course, you got to spin up the, the JVM and all that kind of stuff. There again, he was running at 128 megs of configured memory. He could probably bump that up or triple that, and he's going to go try that. I'm waiting to hear from him. But that will definitely shorten the time and everything. I've tried it with both Python and Node.js. They actually run at about the same speed. I haven't really seen much difference there. So that's it. If you guys have any questions, I'll take your questions. The other thing, I just kind of wanted to show you guys, because I promised that I would do this. I talked to you a little bit about Bisbee. These are our Morphes here at the top. And everything. This is actually a little app that we wrote, and this app here is social.morphe.com is using the APIs that were developed. So if you want to try it out, you can go out to the site. You need a Twitter account to get on. If you really like politics, definitely go out to it. It's a way that you can read a political feed, Twitter feed, and basically give your reaction to how you feel about that feed. And you can play around with the morphemes and everything. So questions?
For the load testing, how did
Yes.
that play into your pricing model? Like, if you were exhausting these containers, did that like spike? Did you have to coordinate the tests so that?
Yeah, so I was a little concerned about that because I'm sitting here saying, all right, I'm on the free tier. Do I want to really use up all my stuff? But it was very early on. And you know what? It's the price of doing business. And my thing is I'm not, the load test that I'm doing, I'm not doing it multiple times a day. You know, I've made a big change, or I knew my APIs are stable at this point. I want to go and verify that they really can handle the load. That was my thought, my mindset.
And then on AWS, they don't charge you for throughput, or?
For that one, no, not for what I'm doing. Now, if you're accessing S3, like you're pushing data into S3 or getting data off S3, there is an access charge, I think, how many puts and gets that you can do. But we still, in that case, I don't even think we've been charged yet for any of those, and we've done thousands of them.
Building off of that, could you see a point where, like, under just a heavy sustained load, it'd actually be cheaper to run your own servers, or if they price Lambda in such a way that it's really almost always cheaper just to keep a heavy load?
The price model that I looked at, there again, calculator is not the easiest thing to use sometimes. I found it cheaper to use Lambda for the number of calls. Like, you know, I looked at, I think, what was it, 5 million calls or something a day, and you know,
Still cheaper.
yes. Now, if you have to run your Lambda function up to max memory, and it's going to run for, I think the max runtime is 5 minutes on a Lambda function that you can have, and then it shuts down. Yeah, at that point, it's probably not the right, you know, that's not the right service to be using, or Lambda is not the right service to be using. You probably want to use your own server.
Does AWS provide any kind of metrics where you can like log in and see the average runtime on
Yes.
different things?
Yeah, so let me show you that. So there's a couple places that you can see it. You can go to this monitoring tab, and you can kind of see the count, the duration, which gives you the averages, the min, the max, you know, any errors that were happening. And then you can actually set up throttling also, so that your Lambda function can only be called so many times. And you can see the throttling stuff. Now, you're probably thinking, oh, well, that's not really, I don't like these graphs. You can go into CloudWatch, and then you can actually start building dashboards and that kind of stuff. And like I said, set alerts up so that you can be notified when certain
So that way
things
you can
happen.
create different memory levels and find out which
Yes.
one is the best for each
Yep.
of your functions.
Exactly. Because that will allow you to, CloudWatch actually has a graph in there. It actually shows you average or total memory use for your Lambda function. Other questions? Sure.
As you're breaking your services down into more nano services, do you find it that it's difficult to manage dependencies between your lambdas, and how do you deal with
So what I did is, you start to see a pattern after a while that you have this maybe a core library that you're always using. Like for my case, all my functions have this account model that it needs to get account IDs. It also has, it's more like an admin type model where you can do login and that kind of stuff. So I started taking that code and I broke it out into its own library. And basically, you know, it's on you know, Git repository. And then all my other Lambda functions have their own Git repository, and they just suck in that common one. So if I need to, you know, you're not replicating that code. So if I have a bug in the common one, of course, now I have to go fix it there, but then I have to go and update all the Lambda functions.
Have you started using private NPM repos?
No, because I didn't like the cost. Yeah, but I really want to do that. But npm allows you to point to a Git repository, and you can pull it in. You have to do some special things with the keys and all that kind of stuff. I think I had to jump through some hoops, but I would love to get a private npm. One day we may, but right now I'd rather spend my money someplace else.
Did
Yes,
you
sir.
have all this in kind of like one project, and if you checked it in, it would then roll out and deploy all the individual
You could.
microservices, or were they separate?
Mine were separate, but you could, if you wanted to put everything into one Git repository or one repository, you could write a utility that basically said, go deploy this, go deploy this, go deploy this, and it could separate the code out. But I found it easier to manage. Each one of my resources becomes a Git repository for me, and I can test everything right there and then move to the next one. Because really, they did different things, so I didn't want to mix that code. Other questions?
So you demonstrated locally you can run unit tests and see if they succeed or fail. If you were going to do an end-to-end test, so if you wanted to just test your API or whatever, you really have to do that in the dev environment in the cloud. You can't run a local copy. Is that right?
Yeah. Exactly.
Wow, 9:30.
Yeah.
Like time it down to the minute?
Yes. I had to skip some stuff, but if anyone wants to, I know we're out of time and everyone's busy, but if you want to hang around afterwards, I'll stay here and answer any questions that I can. By the way, I'm not an expert at this. This is just how I went through it, but boy, it was a lot of fun. I really enjoyed doing this. So, thanks,
Well,
Ernest.
thank you, Michael. Appreciate you presenting.